In this section on interest rates, we explain how interest rates relate present and future values, how to deal with interest rates that are paid more than once each year, and how forward rates are used to relate values at two different future dates. I've included a number of examples and exercises in this section and in later sections. When you come to these, I encourage you to pause the video and try to work out the answer before coming back here to check your work. Let's look first at how interest rates relate present values to future values. If we invest, for example, $100 today at an annual interest rate of 2% for 1 year, that will give a future value that is equal to $102, because 1 year from now we'll get back the $100 we invested, and in addition we'll earn 2% interest on that $100. 2% interest over 1 year on $100 is $2. If, on the other hand, we discount $100 for 1 year at an annual rate of 2%, that will give a present value of $98.04. If you like, you can think of this as being equivalent to saying that if we were to invest $98.04 today for 1 year at 2% per year, we would end up with a future value of $100. When interest is paid more than once during the life of an investment, we have to take into account the effect of compound interest. That is, the fact that we will earn interest on the interest that we receive. Suppose, for example, that we invest $100 for 2 years at a rate of 2% per year. At the end of 1 year, we'll receive an interest payment of $2. This can be reinvested for the second year, so that in the second year we earn interest not only on our $100, but on the $2 of interest that we received at the end of the first year. This will give us a total future value 2 years from now of $104.04. That's 4 cents more than we might have imagined if we had only taken into account the $2 in interest we earned at the end of each year. We must also take into account compound interest when discounting. Thus, for example, the present value of $100 discounted for 5 years at 2% per year would be $90.57, which we calculate by dividing the $100 by 1 plus 0.02 raised to the 5th power. Some financial instruments make interest payments more than once each year. We must also take into account the effect of compounding when we calculate the present or future value of these instruments. For example, if we invest $100 for 5 years at an annual rate of 2%, with interest paid in equal installments twice each year, then the future value of the investment will be $110.46. It's time for an exercise. What is the present value of $100 to be paid 5 years from now when discounted at a nominal rate of 5% compounded semi-annually? To solve this problem, you'll need to combine ideas from the previous 2 examples. I've prepared an Excel workbook to help you work through the exercise. So pause the video now, go to the workbook, and try to find an answer to the problem. When you think you've worked out the answer, I prepared an Excel workbook to help you solve the exercise. The workbook contains 2 tabs, one labeled Questions and the other labeled Solutions. Pause the video now and go to the workbook and try to find an answer to the exercise. When you think you have the answer, check the Solutions tab or come back here and start the video. Here's the Excel workbook that we've set up for the exercise. You remember that we wanted to calculate the present value of $100 to be paid 5 years from now when discounted at a nominal rate of 5% that is compounded semi-annually. So here in cell B4, we'll enter the future value, which is 100. And we're going to be discounting at an annual interest rate of 5%. So we'll enter that as 0.05. Over a 5-year period with compounding twice per year. To find the answer, we need to use our present value formula, but taking into account discounting. So we're going to take the future value of 100, so we write equals 100, and we're going to divide it by the discount factor, or the discounting factor, taking into account the 5% rate per year with discounting over a 5-year period and semi-annual compounding. So we divide by 1 plus the rate per period, which is the 5% annual rate, but paid in 2 equal installments. So we divide by 2, and we're going to raise that whole factor to a power equal to the number of periods over which we're compounding, which in this case is 5 years times 2 periods per year. Putting all that together gives a present value of 78.12. If you get confused during any of the exercises, you can always check the Solutions tab for guidance about how to work out the answer. Okay, now that we have the answer, let's go back to the presentation. Using the Excel workbook, you should have found that the present value was $78.12. The calculations that we performed there are summarized in the formula on the screen. Since the future value is the present value multiplied by the growth factor, the present value is the future value divided by the growth factor. As we showed in the workbook, with an annual rate of 5% compounded twice per year and discounting over 5 years, or if you like, 10 periods, since there are 2 periods per year, we end up with a present value of $78.12. Sometimes we want to know the effective annual rate that corresponds to a given nominal interest rate, taking into account the number of periods over which we compound each year. We call the promised annual interest rate the nominal rate, and we call the effective annual rate the return per year taking into account the compounding frequency. The effective annual rate is sometimes known as the annual percentage rate. Since the effective annual rate is how much we actually earn over the course of the year, it can be related to the nominal rate by applying the nominal rate, taking into account the number of times that we receive interest payments during the course of a year. In the formula, this is represented by M. Turning this formula around tells us how we can calculate the effective annual rate. It's time for another exercise. What effective annual rate corresponds to a nominal rate of 3% compounded 4 times per year? You'll need to use the formula from the previous slide that relates the nominal rate to the effective annual rate. Once again, we've set up the problem in an Excel workbook. So pause the video, go to the workbook, and try to find the answer. And when you think you have the answer, come back here. So we're back in the Excel workbook again, now looking at the effective annual rate exercise. You'll recall that we want to know the effective annual rate that corresponds to a nominal rate of 3% that is compounded 4 times per year. using the rate of 3% per year with a compound frequency of 4, we know that in order to calculate the answer, we have to take the nominal rate, take into account the compounded frequency, and work out what actual or effective return we would have earned had we earned the nominal rate at that compounding frequency. So we take 1 plus the rate per period, which is the nominal rate, divided by the compounding frequency, and we raise all of that to the power of the compounding frequency, in this case 4, and then from that we have to subtract 1 using the formula that we showed in the presentation. That gives us an effective annual rate of about 3.03% per year. And once again, if you get confused, you can look at the Solutions tab to see how to find the right answer.